Used to be you could just walk out your door and stumble on a new element. Okay, maybe not quite that easy. This year, 4 new elements officially made it on the periodic table, completing the 7th row. But have we found all the elements that are out there? The first recorded discovery of an element was phosphorus, symbol P, which was isolated in 1669 from, you guessed it, P. Elements like copper and gold were known for millennia before that, but it wasn't until the late 1700s when modern ideas of chemistry emerged and people recognized that elements are substances that could not be decomposed into 2 or more other types of stuff. That sparked a bit of an element gold rush. Some elements were found by careful measurement of boiling points. Others were discovered in the air. Many were discovered in ores and minerals collected from around the world, including 7 from a single mine in Jitterby, Sweden. Every element from 1 to 92 had been found in nature by 1939, with one exception. Looking at you, technetium. Every element that came after was made in the lab. Why? Many elements after uranium aren't stable enough to last very long in the real world. Plutonium-246 is like a junior high romance, having a half-life of about 10 days. In other words, it takes about 10 days for half of that plutonium to decay into lighter, more stable elements. Some of these elements just last a few seconds. Since we're not going to find them out in the wild, chemists and physicists have had to make them in a fancy lab. And how does one go about making an element exactly? With particle accelerators. The king of these monster machines, the Large Hadron Collider at CERN, can boost protons to near the speed of light. Okay, quick recap about atoms. They have positively charged protons and neutral neutrons in a densely packed nucleus, with clouds of negatively charged electrons around them. Stable atomic nuclei hold together thanks to something called, no kidding, the strong force. But protons don't really like each other. Repulsion between these positive protons tear bigger atoms apart. Think of it as a crowded subway car. Just like people, the more protons that get crammed into a space, the more they want to get out. Sometimes called atom smashers, particle accelerators fire neutrons or even whole nuclei at ludicrously high speed into larger atoms, and then scientists look for new elements in the shrapnel. Chemists like Glenn T. Seaborg figured this out in the 1940s. He started by firing off some deuterium nuclei at uranium. That resulted in a new element named after everyone's favorite dwarf planet, plutonium. And once you get a new element this way, you can fire other particles at it to make even heavier elements. But finding new elements got harder as they got heavier, since particle accelerators can't handle heavier elements. So scientists needed heavy ion accelerators and more sensitive detectors to get to the next batch of elements. Eventually, chemists and physicists were able to fill in elements 93 through 118. But why go through all this trouble? Well, some of those earlier human-made elements found practical purposes, like for example, plutonium powers space probes, or americium's used in smoke detectors. Scientists also want to find new elements so they can test theories about how atoms behave. Since atoms, make up everything, it's important to confirm or challenge those ideas. Despite some attempts, we haven't had any success in the hunt for elements 119 or 120. See, when scientists made element 118, they smashed calcium ions into the element californium. In the same way, they wanted to use einsteinium as the target for element 119. But there simply isn't enough einsteinium in the world to do that experiment. At some point, though, these huge elements are just going to get too big to be stable. Right now, some of the highest numbered elements only exist for a few thousandths of a second or less. It's possible that some might not even last long enough to be detected. It may be that element 121 is just not meant to be. Because of the way neutrons and protons arrange themselves in the nuclei of atoms, certain atomic numbers make for a more stable nucleus. These combinations are called magic numbers. It's possible that element 114 is a magic number nucleus, or maybe it's element 120, or maybe element 126, but there's no guarantee we'll ever get that far. So to sum up, have we found all the elements? Probably not, but we might be getting close. So welcome newest elements, nihonium, moscovium, tennessine, and oganesson. What would you call element 119? Let us know in the comments and check out these videos for more elemental goodness. Thanks for watching.